FP1 numerical methods, example 3. We've gone from one extreme to another here. Example 2 we really couldn't solve by algebraic methods. Example 3, well, how would you find the positive square root of 15? Well, you'd just use your calculator, wouldn't you? It does raise an interesting point, though, that back in the olden days when we didn't have calculators, people did have to have alternative methods to solve equations like this. So whereas we would literally just say, well, x would be the square root of 15, whatever that is, type it in your calculator and work it out. But we'll go ahead and use interval bisection. But what you might want to do now is actually just work out root 15 on your calculator, and then we'll see how accurate our answer is. So we're going to use interval bisection to find the square root of 15 to one decimal place, and we're after the positive root, so we don't need to worry about the negative one. Now, the first thing we have to do is make sure that the equation is rearranged to be in the format equals 0. So the function that we're going to work with is going to be x squared minus 15, because I'm rearranging x squared minus 15 equals 0. It's got to be in the format equal to 0 because we're looking for roots. We're looking for where the function has a value of 0. Now, it hasn't suggested an interval to us here, so you might want to just pause the video and have a think about what interval you think the square root of 15 would lie within. Now, you may have thought to yourself, well, square root of 15 is pretty similar to the square root of 16, which is 4. It's going to be a bit less than that, so I think it's going to be in the interval, say, between 3 and 4. And you'd be right to think that, because if you work out f of 3, that would be 3 squared minus 15, that gives you minus 6. And then f of 4, 16 minus 15 is 1. And so we can say that there is a sign change. And so the root is in the interval 3, 4. But that's almost common sense, really. We don't really need to do much calculation there. So draw ourselves a line for 3. 3 is negative, 4 is positive, and we're doing interval bisection, so we start with 3.5, f of 3.5, sub it into the equation we have here, and we get minus 2.75. It's obviously less than 0. Right, pause the video, finish it yourself, and see if you can get this to one decimal place. So, we're not interested in this side now because we're looking for a place where the sign change occurs, and I think the midpoint of this half is 3.75. So if I sub that in, it works out to be minus 0.9375. Again, less than 0. So because we're looking for a sign change, we don't want that half. We want this half where it goes from negative to positive. Halfway between these would be, again, if you can't think what it is, add the two endpoints together and half it. That would be 3.875, halfway in between. And if you sub that in, it's just about positive, 0.0156 I got. It's greater than 0, so it's positive. So we know that the root is going to occur somewhere in this interval here. So I'm going to now start another picture underneath because I'm running out of room on that one. So I know that we've narrowed it down to 3.75 at one end, which is negative, and we have 3.875 at the other end, which is positive. So I'm zooming in on this little interval here where the sign change occurs. Midpoint of this one, 3.8125. Try that. And if you try that, I got a negative answer, minus 0.46 or so. Negative. So again, we're looking for a sign change, so this half would be the one that we would dismiss. And you could keep going and going and going like this. I did about another 3 or 4 iterations. They would never ask you to do that many in an exam. My next one was 3.84375, and that worked out when I substituted it in to give us a negative value. So that would be the middle of this one, negative value. And then I worked out the midpoint of this one, and that was 3.859375, and that worked out to be negative. And so you could keep going and going, but what we're looking for is the answer, if you look back at the question, correct to 1 decimal place. Now you can see which way this is going really. It's going to get closer and closer and closer to 3.875. So it's going to be somewhere in this interval. Now, because we only want it to 1 decimal place, it's obvious that whatever we get in this interval, it's going to round to something around about 3.859, something in that region. And to 1 decimal place, that is obviously going to round to 3.9 to 1 decimal place. So the root is 3.9 to 1 decimal place. And if you look back at the calculation you did right at the beginning of the question, the square root of 15 is indeed 3.9 to 1 decimal place. So this method works.